This video is about the properties of exponents, and we really should be calling this the laws of exponents. I call it properties because we're going to be talking about products, quotients, and some of the consequences that come from that. So here we have 5 to the fourth power times 5 to the third power. Now, if I'm going to actually use the laws of exponents, I actually have to have the same bases before I begin. And what 5 to the fourth power means is 5 times itself 4 times. And I'm then multiplying it by another 3. So when I write it in expanded form like this, I get 1, 2, 3, 4, 5, 6, 7. I get 5 to the seventh power. The condensed form of 5 to the seventh power, looking at this over here, it kind of helps to understand that if I have the 4 and the 3, when I'm multiplying, I actually have 5 to the fourth plus 3 power, which is 5 to the seventh power. Let's try a couple other problems here. So if I have 3 to the third power times 3 to the eighth power, I think you can figure it out already that I'm just going to simply add the exponents. I'm going to write it like this. And the answer is 3 to the 11th power. And if I wrote this out in expanded form, I would have the base 3 written 11 times. So here we have 4 to the second power times 4 to the third power. And the rule says that I'm adding, so I get 4 to the fifth power. And whatever our base is, the rule is that the n plus m powers are going to give me my answer. So this time what we're going to do is we're going to look at 4 squared, and instead of multiplying it by another exponent, I'm going to raise it to the power of another exponent. And when this happens, it's the same as having 3 sets of 4 squared. So this is 4 squared times 4 squared times 4 squared. And if I wrote this in expanded form, I would have the base 4 written 6 times, and the final answer this time is 4 to the sixth power. So when I have a power of a power, I'm raising this power to a power of 3. What I do in this case, here I'm multiplying them, whereas in the prior case I was adding them. So our rule here is going to be that whatever our base is, that if I had that raised to the m power, it would be b to the n times m. Let's look at another example. So if I have 5 to the fourth power, and I was raising that to the 10th power, I would multiply these and I would get 5 to the 40th power. Let's look at a couple of examples of how it works with quotients. So here we have a quotient where I have 5 to the fourth power and 5 to the third power. And just as with the product rule, which adds the exponents, in division, we subtract the exponents. So when I have 5 to the fourth divided by 5 to the third power, it's 5 to the fourth minus 3. And this would equal 5 to the first power. And just giving this an expanded form to show you, this might make a little bit more sense if I write it in expanded form for the numerator and expanded form for the denominator. Since I'm multiplying all these, I can simplify this by dividing each one of those 5s with 1 from the denominator. And what I'm left with is 5 in the top and 1 in the bottom. So this is 5, or 5 to the first power. Now there's an interesting consequence that comes from the quotient rule for exponents, the quotient law. So let's take a look at that. So in algebra terms, if I have a to the n divided by a to the m, what I get is a to the n minus m. Now, if the exponents of n and m in this situation were the same, say I had a to the fourth power divided by a to the fourth power, what we would have is a to the 4 minus 4, which is a to the 0 power. And the consequence of this is that whenever you have one number over the exact same number, for example, if I had 4 over 4, this would equal 1. If I have 3 over 3, this would equal 1. And a to the 0 power equals 1 because a to the 4th divided by a to the 4th would also equal 1. So the reason that we get this rule, anything raised to the 0 power equals 1, stems from the law of exponents involving quotients where the numerator and denominator are the same, and it results in us getting a 1. Let's take a look at some other consequences. So here we have a situation where it's quotient, but at the numerator, it's looking at a product of powers. So if I'm going to simplify this, I want to take care of this numerator first. So I have 7 to the 5th times 7 to the 3rd would be 7 to the 8th over 7 squared. And then for these two, I would subtract the exponents. So I would have 8 minus 2. So this is 7 to the 6th power. So I tried to make something that looked ugly, but the truth is just handle this in steps and you'll be fine. I would treat each one of these fractions as individual problems. So I would do the product first here, and I would have y to the 8th times y squared is y to the 10th. I'm simply adding the exponents, and I'm dividing by y to the 7th. The next one, I don't have anything other than the division, so I'm just going to subtract the exponent. So this one would just be y to the 4 minus 1, which is y third. And this one would just be y 7th divided by y squared, which is y to the 5th. And I can simplify this one over here by simply subtracting. So y to the 10th divided by y7 is y to the 3rd. And then I have these three terms are being multiplied. And I just simply add all of those exponents. So 3 plus 3 is 6, plus 5 is 11, and that's the final answer. So this problem kind of enters into another topic that's going to be covered in the next video, and that's when your resulting answer gives you a negative exponent. So with the same rule here, I have y to the 5 minus 7, which is equal to y to the minus 2. And y to the minus 2 is the same as 1 over y squared. Let's take a look at one more example like that one. So here we have 6 to the 8th power divided by 6 to the 9th power. So I would have 6 to the 8 minus 9. That would give me 6 to the minus 1. And that is equal to 1 over 6. The answer is 1/6. There's a link at the end of this video to take a look at some cases for negative and fractional exponents.
That was easy.